This is problem number 8 from section 3.4. In this problem it says, suppose that a person's heart rate, X minutes after vigorous exercise has stopped, can be modeled by this function. The output is in beats per minute, where the domain of F is 0, less than or equal to X, less than or equal to 10, between 0 and 10 minutes. For part A, they want us to evaluate the function with an input of 0 minutes. So they're looking to see what's the heart rate of the person. Heart rate is f of x. Maybe we should write that down. Let's go. F of x is number of beats. And x is equal to minutes. Okay. And it's minutes after stopping. So let's start with part A. They want us to evaluate f of 0. So f of 0 means we're going to take this function, plug in 0 for it. So that's 4/5 0 minus 10 squared plus 74. 4/5 times, well, this will be negative 10 squared, so it's 4/5 now times 100 plus 74. 4/5 of 100 is 80, so it's 80 plus 74, which gives you 154 beats. So it's 154 beats in that minute. Let's evaluate now f of 4. So keep in mind, this was 0 means 0 minutes after finishing. So basically, as this person finishes, they're 154 beats a minute, which is pretty good. Now, they wait 4 minutes afterwards. So you plug 4 into the function. 4 minus 10 squared plus 74. This is now 4/5 of, well, this is negative 6 squared, which is 36 plus 74. 4/5 of 36. So 0.8 is what 4/5 of times 36. That's 28.8 plus 74. So plus 74, 102.8 beats. So 4 minutes after exercise, they've lost 50 beats per minute, right? So their heart's starting to calm down a little bit. So that's the interpreting part. What's this mean? It means at 0, directly after they finish working out 154 beats per minute is what the heart's going. 4 minutes after, 4 minutes of rest afterwards, they're down to 102.8 beats. They've lost 50 beats per minute. Okay, part B. Part B, they say, estimate the times when the person's heart rate was between 100 and 120 beats per minute, inclusive. Now, we've got to, in this problem, you're going to run into a situation where you can do it like 2 different ways. And I'm going to show you those 2 ways, essentially. So, well, I'm not going to show you both ways. I'm going to show you the way I think you should do the problem. So let's first of all take this and say that this function has to be greater than or equal to 100. So we're going to say 4/5 x minus 10 squared plus 74 has to be greater than or equal to 100. And let's also do 4/5 x minus 10 squared plus 74 is less than or equal to 120. All right, so what we're doing is we're trying to figure out when is this person's heart rate between 100 and 120. That's our goal. So notice we have a quadratic greater than or equal to 100. So we're going to solve this. When we solve this, we're actually going to get 2 different answers here. One of them is not going to make sense. And we're going to use this piece of information that our time needs to be between 0 and 10 because that's what we're looking for. We want to know when was that person's time between 100 and 120 beats per minute. Let's start this side by solving. So we're going to subtract 74. And that's going to give you 4/5 x minus 10 squared greater than or equal to 26. Then we're going to divide by 4/5. So divide by 4/5. Divide this side by 4/5. And you'll get x minus 10 squared greater than or equal to, and let's see, 26 divided by basically 0.8, that's what 4/5 is 32.5. All right, now at this point we got to square root each side. So we're going to square root here and square root here. We're going to end up with the root of x minus 10 squared. It has to be greater than or equal to plus and minus root 32.5. Now here's an issue that we're going to run into. So at this point, we're going to need to separate this into two problems, and you'll see that here in a second. First of all, the square root cancels the square, and we get x minus 10 greater than or equal to plus and minus, let's see here, root of 32.5, and we get 5.7. Now we're going to add the 10 over, and we get x has to be greater than or equal to plus and minus, so we're going to say 10 plus and minus 5.7. And when we add the 10 and the 5.7, and then we subtract the 10 and the 5.7, here's what we have to do. And I should have switched this right away. So because of the plus and minus, at this point when we do the square root, and actually I'm going to kind of cancel this out. At this point when we do the square root, and we start to put the plus and minus in, I need to split this. So when we do the square root, at this point I need to say, okay, x minus 10, there's two options here. Option 1 is x minus 10 greater than or equal to positive 5.7. Or x minus 10, because this is going to be a negative now, right? Because we're flipping the sign, we could be less than or equal to negative 5.7. Okay, at that point when we do the square rooting, we need to split it into two different inequalities, and we've done this before whenever we had this whole plus and minus deal, right? Especially with absolute value. Remember with the absolute value, when we had to use the minus part, we had to flip that sign. That's what we've got to do when we do the square root of each side. Okay, so because we're doing the square root of each side, we do the two separate situations. I'm going to add the 10 over on this side. That's going to give you x greater than or equal to 15.7. Remember, that's minutes. Or add the 10 over, I get x less than or equal to, when I add 10 over, I get 4.3. Now, which of these makes sense for us? Well, it tells us that in the problem, we're looking for we're looking for being between 0, and you can't see that right now. We're looking to be between 0 and 10 minutes. All right, 0 and 10 minutes. Well, right now we're at 15.7. I slide down. 15.7 greater than or equal to that, and less than or equal to 4.3. This side actually doesn't make any sense. So we're going to cross that out. This is the only portion of this quadratic inequality that we can actually use. So this is the portion that we're going to use right there. Now let's go ahead and solve this side. We're going to subtract the 74 over. So subtract 74 here. We got 4/5 x minus 10 squared is less than or equal to, 2646. Divide by 0.8 basically, and we get x minus 10 squared less than or equal to 46 divided by 0.8 is 57.5. Now we're going to square root each side. So I'm going to square root this side and this side. That's going to set up two different equations just like I did right here. So I'm going to have x minus 10 less than or equal to the root of 57.5 is 7.5. We're going to go 7.9. And the other version, or we're going to have x minus 10 greater than or equal to negative 7.9. Add 10 over and you see x is less than or equal to 17.9. And add 10 over, we get x is greater than or equal to, this would be 2.1. All right, again though, we look at the top and we see this has to be between 0 and 10 minutes. So this x less than or equal to 17.9, that's not going to work for us here because we already know that x has to be less than or equal to 4.3 here. So this thing is basically insignificant. We're going to forget about that. And we're only looking at the x greater than or equal to 2.1. So x has to be greater than or equal to 2.1, and it has to be less than or equal to 4.3. That means the person's beats were between 100 and 120, somewhere between 2.1 minutes and 4.3 minutes. So let's write that. Heart rate was between 100 and 120 at minutes 2.1 less than or equal to x less than or equal to 4.3. So between 2.1 and 4.3 minutes. Hope that makes sense.